Okay, so we're going to keep talking about the Lorentz transformation today, and I think we wrap it up in this video. If not, then we'll finish it here soon, but we'll see how far we go. So the Lorentz equations here, these can help us relate the position and time of some event in two different reference frames. So we talked about that a little bit in the last video, might be worth checking out. And now we can use this to predict some of the things we've already learned about special relativity, like, for example, length contraction, which we're about to do. So let's say we have, I'll just put this rod here. This rod, and let's say we have this observer O prime. And what he measures is that this is x prime 1, and this is x prime 2. Okay? So, and this is within the little bubble here. So, the length as measured by this observer here, and this observer is moving at a speed u, is L naught is x2 prime minus x1 prime. Okay? If we just draw a little coordinate system here, and we let the center be here, or wherever it might be, but that's the coordinate system we're using. Okay? Now, at the same time, let's say we have an observer O. Maybe I'll draw a little person. We have an observer O. This is O prime. I use the O prime to make the head. O prime is watching this whole contraption move to the right. Okay? Well, he's going to have a different coordinate system, and we'll call that x. In fact, we'll do x comma t, and over here it'll be x prime t prime. So the x position and the time. Now O, first off, O must measure the two ends, so here and here, must measure x1 and x2 at the same time. At the same time. Now, why is that? Because if, let's say, O measures here, and then he decides he's going to look out the window for a little bit, and then he wants to measure this part. Well, this whole system is moving. So you're going to get here, and then by the time he looks back, maybe this second part is way over here. So you're going to measure this huge length, L, and that's obviously not the length of the rod. So he has to measure those two events, the ends lining up at the same time. Otherwise, he's not going to get an accurate measurement. Hopefully that makes sense. Okay, now let's suppose O prime sets off a flash at x prime comma t prime, and O sees the flash at x comma t in his coordinate frame. Nothing crazy, right? So let's say then O prime sets off a second flash that looks as if it goes off at the same time as the first flash. Now, I could do a video on this if you guys would like, about events lining up and being in sync. Basically, when the flashes would appear to be in sync would be different for both observers. And we want it to appear to be in sync for O. Okay. And we'll say that's at x prime 2, t prime 2. T prime 2. Which just corresponds to x2 comma t2. Okay. So let's see if we can piece this together. We have x prime 1 is equal to x1 minus u t1 all over the square root of 1 minus u squared over c squared. And these are our Lorentz transformations from the first video. So x prime 2 is going to be using the exact same logic. Again, if you're wondering where these equations came from, watch the previous video on this and you will see. But these are our transformations. Now what we want is we want to know the length. So that would just be x prime 2 minus x prime 1, which is equal to x2 minus ut2 over square root of 1 minus u squared over c squared minus x1 minus ut1 all over the square root 1 minus u squared over c squared. Okay, so that's the same thing, just simplifying it as x2 minus x1 minus u times, I'm factoring out the t's, t2 minus t1, all over the square root of 1 minus u squared over c squared. Okay? And we can think of that as just being x2 minus x1 over the square root of 1 minus u squared over c squared minus u times t2 minus t1 all over the square root of 1 minus u squared over c squared. Perfect. So we have that lined up now. And let's remember real quick. That T2 should equal T1, right? Because we want the two lights to go off at the same time. So for that to be true, if that's true, which it is, then this is 0, which means this whole thing is 0. Okay? So finally, we have x prime 2 minus x... I got those backwards. No, I didn't. X prime 1 equals what's left, which is just this, all over the square root 1 minus u squared over c squared. Now this is our proper length, L naught, and then this is the measured length, L. So we could say L naught times the square root of 1 minus u squared over c squared, if we just multiply over, is equal to L. And there we go. This is the equation that we got before, just a new way to get there. So this was length contraction. We also have velocity, which I might do tonight, I might do tomorrow, not sure yet.